Hello and welcome to the Fire Alarm System course. I am Engineer Syed Abid Haider Rizvi and I will be presenting this course to you. I have prepared this course specifically to allow people who are interested in learning about fire alarm systems to understand what a fire alarm system is and also to be able to design at the very least a basic fire alarm system with utmost ease. Now, in order to make this happen, I have tried to explain all the basic important components and topics related to fire alarm systems in a simple manner without going into too many details that may confuse people. For the same purpose, the course has been divided into two main sections, that is, one, understanding a fire alarm system, and two, designing a fire alarm system, which have been broken down into subsections for ease of understanding. So before we begin the course, let's first talk about the importance and the need for having a fire alarm system. Now, as we all know that throughout the ages, fires have caused a lot of damage to both property and life due to the inability to detect and extinguish fires in their early stages. If a fire can be detected in the early stages of its development, then it can not only be contained and extinguished early, but it can also allow for the timely evacuation of the occupants in the premises by alerting them to the presence of the fire. This is where the fire alarm system comes into play. These systems allow for the early detection of the fire and the early warning of the occupants to the presence of a fire before it reaches dangerous levels. The fire alarm system can also be interconnected to other building systems as well, which further assist in the same, and also can be connected to the fire station so that whenever a fire occurs, the fire station receives a signal as well, allowing for proper action to be taken in time. So, keeping all this in mind, let's move on to the course to get a better understanding of the fire alarm system. As stated before in the introductory video, this course is made to allow anyone at all who is interested in fire alarm systems or learning about fire alarm systems to at the very least be able to design a basic fire alarm system. Now this course is divided into two main sections with their own relevant subsections, namely understanding a fire alarm system, which will include all the details about what a fire alarm system is and what it consists of, and designing a fire alarm system. Now this section will contain all the relevant data which is required to design a basic fire alarm system based on the information available to the designer. As you can see, each section has its own subsections mentioned. So with that in mind, let's move on to the first section of the course. So now let's move on to the first section, that is understanding a fire alarm system. So what is a fire detection and alarm system? As the definition states, it is a system or a portion of a combination system which consists of components and devices which initiate either a fire alarm signal or a supervisory signal and provide the appropriate response based on the type of signal that the fire alarm control panel receives. Now, the response could be the activation of either a mass notification system, or it could be of any a number of notification appliances to allow the signal to be perceived by the occupants. Now moving on, let's talk about the international standards and the local standards and codes that are used for the fire alarm system design and installation. The international standards and codes are normally followed and accepted almost all over the world. Some of the common examples of the international standards and codes that are applicable for fire alarm system and design are NFPA 72 and the International Fire Code, also known as IFC. For the local standards and codes, well, these are standards and codes that are followed locally in either the district or the country or the area where they have been developed. They are at times they are required to be followed by the AHJ, that is the authority having jurisdiction in place of the international standards and codes. Some examples of these local standards and codes are the British standards, which are normally followed in Britain, or the Indian standards that are followed in India, or the factory mutual codes, which are applicable to the buildings that are insured by the factory mutual insurance company, which are followed in the United States. All right, so now let's get to the next part, which is about the types of fire alarm systems. Now, there are basically two types of fire alarm systems, which we will discuss individually, that are used throughout the world. The first one is the addressable type of fire alarm system, and the next one is the conventional type of fire alarm system. So let's start off by talking about the addressable fire alarm system first. Now, it is a system in which each and every single device connected to the fire alarm control panel has its very own unique address, which helps in identifying each type of device. And all the devices are connected using class A wiring and are part of a loop, which starts from the panel and returns back to the panel and terminates there. Now, the addresses on each of the devices in the loop help to identify which devices have been activated or have a fault in them, and along with their actual location, so that it can be easily identified and the problem can be resolved. Whether it's a fire alarm or whether it's a fault within the loop or the device, it can be easily identified in that way. So this property of the addressable fire alarm system makes it quite flexible. Now then, let's move on to the conventional fire alarm system. Now, the conventional fire alarm system is a system which is usually connected using Class B type of wiring, in which the wiring starts from the panel and terminates at the end of line resistor, which is installed just after the last device in the zone. So now here each of the devices do not have any sort of address, which make it more difficult to pinpoint their location and to identify which device actually has an alarm or a fault. Instead, the panel simply shows the entire zone or the area where all the devices are connected together, and so this does not make it as flexible and desirable as the addressable fire alarm system. Of course, this type of fire alarm system is especially useful in protecting small buildings or shops or any area that does not require a large number of fire detection devices. Of course, the conventional fire alarm system, owing to this feature, is a lot less expensive as compared to that of an addressable one. But since the addressable fire alarm system is so flexible, owing to the fact that every device has its own address, it makes it more desirable and for use in designing and installation of of fire alarm systems in a large building, because it is a lot easier to divide the fire alarm system for a large building into different zones using different loops. So it's a lot easier using the addressable fire alarm system. So next thing that we are going to do is I'm going to show you a few examples of what a standard addressable and a standard conventional fire alarm system will look like. So as you can see, this is what an addressable fire alarm system will look like. If you take a look at this one, this is your fire alarm control panel, and these are your devices that are connected in the loop. You can see that it starts off from the fire alarm control panel, goes on to all the devices, and then loops back from the last device and connects back to the panel. The same thing is applicable for all your notification devices and notification appliance circuits. Of course, we'll be getting to the types of circuits at a later stage. All right. So now this example is for your conventional devices, conventional fire alarm system. As you can see, this is your addressable fire alarm control panel. Of course, you don't exactly need, you do get conventional fire alarm control panels over here as well. So what you can do is, if you need to connect, what this is basically showing is if you need to connect any sort of conventional devices to an existing fire alarm control panel, addressable control panel, then you can use what is known as a zone module and then connect the devices. As you can see over here, if these devices connected directly to the panel, what would happen is basically it would start off over here. These zone modules would not be present there. It would go directly to all the devices, and the last device would actually have an EOL, an end of line resistor connected at the end. See, this is how you can connect. This is what I was talking about previously. You can see that this is the conventional fire alarm control panel, and you can see that this is one notification circuit, this is the other notification circuit. You can see the end of line resistors connected both over here, as well as for the different zone circuits as well. For example, this is zone 4, wherein this is the first device of zone 4 and this is the last device of the zone 4, and you can see at the last device you have the end of line resistor connected here. Similarly for zone 3 as well. So this is basically what your conventional fire alarm control conventional fire alarm system will usually look like. Also, this is an example of fire alarm control, fire alarm single line diagram. Alright, so now that we finished discussing the types of fire alarm systems, namely the addressable type and the conventional type of fire alarm systems and a description, we're going to be talking about the types of circuits that are involved in a fire alarm system. Okay, so there are basically three types of circuits that are used in fire alarm systems, namely the signaling line circuit or the SLC, the notification appliance circuit or the NAC or NAC, and the initiating device circuit or the IDC. Now, first we'll be explaining the signaling line circuit. Now, a signaling line circuit is basically a circuit pathway, or you could say a loop that interconnects all the addressable devices on an addressable fire alarm system. Basically, what that means is that it is the circuit path that is used to receive and send signals from any of the um, addressable devices on an addressable fire alarm system. Okay, now moving on to the notification appliance circuit. As the name suggests, it is basically that pathway that is used to interconnect all the notification devices such as horns, strobes, bells, speakers, etc. on any type of fire alarm system. It could be an addressable fire alarm system or a conventional type of fire alarm system. Both of these systems have notification appliance circuits, and the wiring for notification appliance circuits could either be class A depending upon the requirement or class B. Now, thirdly, moving on to the initiating device circuit. Now, this is somewhat similar to what to a signaling line circuit does. Okay, this is basically that pathway or that circuit that interconnects all the alarm initiating devices on a fire alarm, conventional fire alarm system. Now, what that means is all your detectors, pull stations, etc., that are conventional type will be connected on that circuit. Means if there's one loop, not loop, one IDC circuit, then you could have any combination of um, you know smoke detectors, heat detectors, and manifold stations with the circuit terminating at the last device using an EOL. This is something that I've already explained in the previous section for conventional fire alarm systems. So that circuit with all the alarm initiating devices, that is basically your initiating device circuit or the IDC circuit for a conventional fire alarm system. Alright, so now that we have finished discussing the types of circuits in a fire alarm system, we will discuss the types of signals that exist in a fire alarm system as well. Now, there are mainly three types of signals that are present in a fire alarm system. First being the alarm signal, second being the trouble signal, and the third being the supervisory signal. So now we will go into a bit of detail in these signals. The first one being the alarm signal. As the name suggests, this indicates the presence of a fire alarm in the protected premises. Now, this fire alarm can be detected uh, using any of the initiating devices like the manual pull station, the smoke detectors or heat detectors, or even the sprinklers that behave as heat detectors, since the fire alarm system is actually interconnected to the sprinkler system. Okay, now what happens is that basically when every time one of these devices initiates an alarm by detection or by manual means, these devices, they tend to send a signal to the fire alarm control panel, which then initiates the appropriate response, normally which could be the activation of a suppression system, or along with notification devices, or just the notification devices, or a mass notification system, or whatever is interconnected as per the requirement of the project, indicating that there is an existing fire alarm condition within the protected premises. So that's about the alarm signal. Now moving on to the next signal, that is the trouble signal. As the name suggests here, this indicates the presence of any sort of fault or trouble that might exist within the fire alarm system itself. It could be within any of the devices, the initiating devices, the monitoring devices, or any of the devices, or even in the wiring. It could be an open circuit ground fault, or uh, a short circuit fault. And any of these, if any of these fault conditions exist, a signal will be sent to the fire alarm control panel, and an LED will turn on in the fire alarm control panel itself, along with a sounder or a beep that will indicate that there is a existing trouble condition within the system. So that completes the trouble signal. Now moving on to the third signal, that is the supervisory signal. Now, as the name suggests, it is a supervisory signal. What this means is that this indicates the existence of any sort of abnormal uh, conditions that might exist in any of the interconnected systems such as the automatic sprinkler system, due to maybe a leakage, uh, a leak, or an abnormal flow or abnormal activation of the sprinkler system without the presence of any fire alarm, existing fire alarm condition. So this sort of a signal basically is called as a supervisory signal. Anytime any of these situations exist, again, since these interconnected systems are being monitored via monitor modules, as if any such system exists, then through the programming of the fire alarm control panel, we can monitor these signals, and there will be an alarm signal that will a signal that will be sent to the fire alarm control panel, and again, just like the trouble signal, an LED will turn on along with a beep, or a buzzer that will indicate that there is an existing supervisory signal or supervisory condition within any of the interface systems. So with that in mind, this completes the supervisory signals and as well as the types of signals that exist in a fire alarm system. So the next topic of discussion will be the basic components of a fire alarm system, that are namely the fire alarm control panel or the FACP, the power supplies, the alarm initiating devices, the notification devices, the interface modules, and last but not least the annunciator, repeater, and mimic panels. So we will try and get into a bit of detail into each of these components, not too much detail but as much detail as necessary. So the first component that we will be discussing and talking about will be the fire alarm control panel or the FACP. It is, as as the definition suggests, it is basically the brain and heart of any fire alarm system. What that means is that basically controls the entire fire alarm system by sending and receiving signals to and from all the devices that are connected to it. Uh, basically what that means is that all the devices such as the smoke detectors, heat detectors, pull stations, notification devices, etc., that are connected to it, they send and receive signals through the FACP. For example, if there is a fire condition that has been detected through a manual pull station, or that's been initiated through a manual pull station, or has been detected by a smoke detector or heat detector, etc., then in that case the signal is first sent to the fire alarm control panel, which then takes the appropriate response by activating either the notification devices or the suppression systems, etc., and also by sending signals to the all the interconnected systems. It could either be a BMS system that could be interconnected to which it sends the signal, or it could be a smoke management system that it activates, and it could either be elevator control or the HVAC control, etc. So either way, this is basically the most important component of a fire alarm system that controls all the aspects of the entire system. So moving on, we will discuss the some of the components of a FACP. Now there are several components of an FACP, but we will I'll just be showing an image about some of the important components that an FACP consists of. Okay, and we will and I've listed down four of those important components here, namely the motherboard and CPU, the power supply unit, the network cards, and of course you have the loop expansion cards. Now, as the name suggests, the CPU and the motherboard are basically the you can say the brain and heart of the FACP itself. This is basically that component that computes or distinguishes between an alarm and trouble signal, etc., sends and receives all the signals. Okay, so that is the motherboard or the brain or the CPU of the fire alarm control panel. And of course the next important unit is the power supply unit. That is basically again one of the most important units, or I would say even more, far more important than the motherboard or the CPU, because this is the unit that supplies the required power supply to all the components in the FACP, as well as to all the devices that are connected to the FACP as well, like the smoke detectors and everything. Okay, so the power supply is connected directly to any main building supply, and through that the power supplied to all the components of the entire fire alarm system, including the components of the FACP. Okay, now thirdly we will talk about the network cards. The network cards are those cards that allow any FACP or any fire alarm system, or that could be, let's say, in one particular building. These network cards, if they're installed inside the FACP, they allow that particular FACP to be interconnected with other FACPs or other fire alarm systems, thereby forming a network. Okay, that could be like a master and slave. You could have a master FACP that is placed in one particular building, let's say an administrative building, and then you have another fire alarm system that is being placed in a smaller building, let's say a control building or of sorts, and these two can be interconnected using the network cards. And the main control panel placed in the administrative building can now monitor the signals and the alarms of the slave fire alarm system that is placed in the control building, thereby forming a network. Now the mediums can either be fiber optic cables, or just your copper cables, depending on the project requirements. And now the fourth component that we will be talking about is the loop expansion cards. Now normally when you get like let's take the example of the notify fire alarm system. Basically in a notify fire alarm system you have a complete unit with the CPU and the motherboard and everything installed all together. Okay, which also contains around 2 to 3 loops within that motherboard itself. Okay, so after utilizing those loops, if you need to add any extra uh, uh, loops or any extra loops uh, within that panel, let's say you have three loops already existing in the panel, you need to expand it to 4, 5, 6, etc. Then what you can do is you can use in loop expansion cards. Okay, and you can install those cards within the FACP, and through those cards you can provide an extra other extra loops for the same fire alarm system, either in the same building or for another building, etc., whatever you want. So that is basically the loop expansion cards. What it means is, in simple terms, it just expands the number of loops that can exist in a FACP. Now moving on, I'll just show you an example of a basic fire alarm system, FACP of a fire alarm control panel. This is for the 4100 ES Tyco Simplex um, control panel, and this is just showing the three bay configuration. As you can see, bay 1, bay 2 and bay 3. Now these are the different components of the fire alarm system. Okay, as you can see, this is the main power supply, the system power supply. This is the CPU installed over here. Of course, for different manufacturers, the you can say the configuration is quite different. This is how it is configured in Simplex. Okay, so then this is the XPS, which is the auxiliary power supply. You can have auxiliary power supplies in as well, that can be remote power supplies or power supplies that are installed within the FACP, etc. as well. Then you have voltage regulator card installed next to the auxiliary power supply. Now this is what I was talking about. These are the MX loop cards, or loop expansion cards that are connected over here, and these are the different modules, two different modules of monitor zone modules that are uh, shown as interconnected over here. All right, so that basically concludes the uh, components of an FACP. So the next component of a fire alarm system that we will be talking about are the power supplies. Now there are basically three main types of power supplies that are used in a fire alarm system, as described over here. A, the main power supplies; B, the backup power supplies; and C, the remote power supplies. Now we will go into a bit of a detail in explaining what these three types of power supplies are. So let's start off with the main power supplies. Now usually these main power supplies are through uh, basically provided through the main building power supplies or the electrical panels via dedicated breakers that are supplied to uh, uh, the system power supplies that are installed within the FACP. So these are the main power supplies that provide continuous power to the FACP in order to operate the complete fire alarm system. Now moving on to the backup power supplies. Now these are the power supplies that usually kick in if in case the main power supplies fail. That is, if the building electrical panel or the building itself loses power, then in that case these backup power supplies, they get automatically turned on, and they could be in the form of batteries that are normally provided using are normally provided and are connected to battery chargers, or they could be a UPS or a generator set that will kick in or start up as soon as the main power supply gets cut off to the FACP. Okay, so now thirdly we'll be talking about the remote power supplies, and as the name suggests over here, these remote power supplies are the kind of power supplies that can be provided at remote locations, that is far away from the FACP or etc., and provided wherever they are required. They are actually portable kind of power supplies, and they are, you could say, they come into the category of auxiliary power supplies, which means that let's say that the main and the backup power supplies are not enough to provide power to all the notification devices or any other devices that may require extra power due to the voltage drop and the long that will be there because of the long distances, the long distance from the FACP. So in that case, you need a separate power supply that will be a lot closer to the devices that require the power supply. In that case, these portable or remote power supplies are come in quite handy, as they can be installed near the um, notification devices that cannot be supplied power through the main power supplies. So in that case, you place you can use these remote power supplies and connect the devices to them, and of course there are options in some of these, there are options of connecting backup power supplies even to these remote power supplies. You can provide batteries for them, or you can directly connect them while connecting them directly to the main building power supply as well. So you have all of these options available as per the manufacturers as well. So well, with that, that covers the main the power supplies components for the fire alarm system. Alright, so the next component that we will be discussing are the alarm initiating devices. Now there are several types of alarm initiating devices that are used to detect any sort of existing fire alarm situation. So the main fire alarm initiating devices are as follows. First, we have the smoke detectors, then the heat detectors, and thirdly, we have the combination multi-sensor detectors. Then we have the flame detectors, then the gas detectors, the manual pull stations, and finally, we have the sprinkler flow switches. Now, moving on, we will be discussing each of these alarm initiating devices in a bit of detail. So first off, the alarm initiating device that we will be discussing are the smoke detectors. As the name suggests, and as per the definition, these are the devices that basically detect the presence of smoke particles that are present in the air around them by either sampling the air or any other means of detection. And there are basically four types of smoke detectors that are primarily available throughout the world. First, we have the ionization type of smoke detector. Secondly, we have the photoelectric type of smoke detector. Thirdly, we have the beam projection type of smoke detector or the beam detectors. Then fourthly, we have the video imaging type of smoke detectors. And finally, we have the duct smoke detectors. Now we'll discuss each and every one of these in a bit more detail. So first of all, we will be talking about the ionization type of smoke detectors. Now, as the definition here states, the as the definition over here states that these type of smoke detectors basically keep on with the help of a little bit of a radioactive element, continuously keep on ionizing the air that they sample and continuously keep sampling in their sampling chamber, and in between two electrodes. Now whenever smoke enters the chamber, what happens that the conductance between these two electrodes decreases, and thereby it reduces the mobility of the ions that are present in the chamber. So this reduced conductance is processed as a signal and then sent as an alarm signal to the FACP from the ionization type of smoke detector. Now there's one point that needs to be noted over here, and that is that the ionization type of smoke detectors are no longer used throughout the world due to the effect that they have on the environment. So now let me just show you uh, a diagram of what exactly is inside a normal ionization type of smoke detector. So here you can see that this is the complete smoke chamber right over here. Okay, and you have the lid, the outer lid over here. Okay, and then you have the inner cover and everything, and here you can see that You have the radioactive foil that contains the radioactive element, which is connected to a positive supply, and then you have the two electrodes, and this is the area in which between which the the alarm will actually get initiated once the smoke enters this area. Then it gets processed. The reduced conductance will then get processed over here within the smoke detector itself, and then it will be sent from the smoke detector to the FACP to which it is connected, uh, as a fire alarm signal. So that well, basically that covers the ionization type of smoke detector. So moving on, the next type of smoke detector that we'll be talking about is the photoelectric type of smoke detector. Again, as the name suggests, it uses the light scattering or the light obscuration principle in order to generate an alarm signal. Okay, so the first principle that we will be talking about in this case is the light scattering principle, which is normally used in spot type of smoke detectors. Okay, now, all right. So, what happens in scattering in smoke detectors that utilize this light scattering principle is basically that the air, again, just like in ionization smoke detector, the air is continuously sampled into a smoke chamber where there is a light source present. Normally, it is an IR LED that is present over there, and there's also a photodiode that is present within the same chamber as well. Now, as whenever smoke enters the chamber, what it does is it starts scattering the infrared light that is present over there, and then finally, when the scattered light hits the photodiode, then that photodiode generates a signal which is then processed and then sent as a fire alarm signal to the FACP to which the photoelectric smoke detectors are connected. Okay, now there's a note that's worth mentioning over here, and that is that the beam projection type smoke detectors or the beam detectors, they are photoelectric detectors itself, and they utilize the light obscuration principle, and we will get to that in a few minutes. So here you can see this is the construction of a photoelectric smoke detector. This is how it actually looks like. Here you have the chamber cover, and this is the smoke chamber. This cover will come on over here, and it will basically cover this entire area. Okay, and here you can see this is the photodiode, and this is the IR LED that will keep flashing. Okay, that will be on the whole time that the air is being sampled, and as soon as the smoke enters over here, it starts blocking the path of this LED. Then eventually a portion of the scattered light that will be scattered because of the smoke will hit the photodiode, and then this photodiode will then generate a fire alarm signal. So that is basically how a photoelectric type of smoke spot type smoke detector works. All right. Now, since we were discussing photoelectric type smoke detectors, and as I mentioned in the note, that the beam projection type smoke detectors, they utilize the light obscuration principle, and they themselves are actually photoelectric smoke detectors. So basically, what these kind of smoke detectors do is that you have a transmitter and receiver unit which is either separate, which is either one unit, and then you have a reflector that will be placed on two separate walls. The transmitter and the receiver will be placed on one wall, whereas um, the reflector or the mirror will be placed directly in front of it on the opposite wall. And this is basically used in large areas where you cannot place too many smoke detectors, where it's difficult placing a large number of smoke detectors over there in large rooms such as auditoriums, etc., or large warehouses. So in that case, that is when these type of beam projection type smoke detectors are very handy. You can cover a distance of up to around 100 meters or more, depending upon the kind of manufacturer and the extension kits that are available for these type of beam detectors. So the principle behind this is that the transmitter and receiver unit, or just the transmitter, will be sending the signal to either the reflector or to the receiver uh, 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 or to the receiver. Basically, if it is like if the transmitter and receiver are one unit and you have a reflector on the other, what will happen is that the transmitter will send a beam of infrared light to the reflector, which will then be reflected back and received by the receiver in the same unit itself. So now the thing is that you have a continuous beam of infrared light that is projected from one wall to the other. Now, any time that smoke interferes or gets in between this beam of light and obstructs it, then the transmitter and receiver unit, or just the transmitter unit if it is separate, will initiate an alarm signal due to the blockage that is being created by the smoke that is present in that particular area. Then the receiver then this signal is transmitted to the FACP after being processed. So next I'm going to be showing you exactly what I'm talking about. So you can see this is an example of the beam type smoke detector, where the transmitter and the receiver are actually separate. So you can see that you have the beam of infrared light that is over here, and you can see that the maximum distance mentioned here is 100 meters, and you have the analyzer unit that is connected to the receiver, and then it's connected to the fire alarm control panel. So whenever a fire will take place over here and come in between this beam, okay, it will obstruct the beam pathway, and then the signal will be generated by the receiver, which will then be sent to the analyzer, and once the analyzer processes this signal, then it will forward it to the fire alarm control panel as a fire alarm signal. Alright, so next, the fourth type of smoke detector that we have is the video imaging type of smoke detector, or the VISD. Now what this means is that it uses real-time imaging via cameras, and specially made or developed processing software to analyze and distinguish between smoke alarm signals and other signals that might exist, or other conditions that might exist within the protected premises. Again, this is basically used for large areas, and it is quite accurate to quite an extent. So again, the signals that are analyzed are sent to a central command center, or to an FACP, or to a cell phone, using various wiring connections or wireless connections, depending upon the requirements of the project, as mentioned here in the definition. So next is a simple example of how it actually works and how the interconnections can take place. You can see the cameras are connected to an analyzer unit over here as well, and then these are either connected to your command center or to the fire alarm control panel, and the same thing can also be connected to your cell phone wirelessly, or through any sort of a wire medium as well. Now moving on, we have the final type of smoke detectors, that are the duct smoke detectors. Now smoke detectors are usually photoelectric type itself, and these are installed basically in a particular, how do I say it, um, container, you can say, in which you have two types of basically sampling tubes, one for receiving the air sample, and the other one for returning the air sample. So basically these are installed on HVAC ducts, inside or out on the outside, depending upon what kind of duct detectors they are, and they are basically used for the early detection of the presence of smoke that may be present either inside the HVAC ducts, for the protection of the HVAC units that are on the roof, or for the building protection as well. So they can be placed on both the supply and return ducts, or on either one of the ducts, either the return or the supply ducts, depending upon the requirement. So next, what we are going to do is we are going to show you what it actually looks like. These are the duct smoke detectors. This is the weatherproof type housing or container that I spoke of. So you'll have the smoke detector installed inside, as you can see over here inside these containers. This is the indoor one, and then as you can see, it is installed on the duct. Okay, so this is the sampling tube, this is the return tube, and you have the end caps over here placed right at the end of both the tubes. And this is how it can be installed. This is how it's installed inside the duct when it is installed inside the air duct, and this is when it is installed outside the air duct. So the next type of initiating devices that we'll be talking about are the heat detectors. As the definition suggests, these are devices that detect the temperature changes that take place within the protected premises and then analyze these changes to determine whether a fire alarm signal exists and then send the signal to the FACP for the appropriate response. Now, there are basically three types of heat detectors that are primarily available and commonly used in fire alarm systems. That is A, the fixed temperature type of heat detectors, B, the rate of rise type of heat detectors, and C, combination of both fixed temperature and rate of rise type of heat detectors. Now, moving on, we will be discussing each of these type of heat detectors in a bit of detail. So, all right, so let's discuss the first type of heat detectors, that is the fixed temperature type of heat detectors. Now, these are the kind of heat detectors in which there is already a preset temperature within these heat detectors. Now, what happens is that if you're using a fixed temperature type of heat detector within a protected premises, and let's say the fixed temperature or the preset temperature is 135 degrees Fahrenheit, that is 57 degrees Celsius approximately. Then if the temperature goes beyond this temperature, that is 135 degrees Fahrenheit, if the temperature of the premises goes beyond this temperature, then the heat detector will analyze this temperature and say that this is a fire alarm signal, and then send this signal as a fire alarm signal to the FACP. So that is basically how it functions. Alright, so moving on, now let's talk about the rate of rise type of heat detectors. Now in this type of heat detector, instead of the temperature, the preset temperature, you have a preset rate of rise. That means that this type of heat detector basically uh, continuously monitors the rate of rise in temperature of the surrounding air within the protected premises. What this means is that, let's say that the preset rate of rise value within the heat detector is set at 15 degrees Fahrenheit per minute. That means it is around 8.3 degrees Celsius per minute. Now, if the rate of the rise of the temperature within the protected premises goes beyond 15 degrees Fahrenheit within the protected premises, that is when the heat detector will sense that there is a fire alarm, existing fire alarm within the premises, and send the signal to the FACP to take the appropriate response. Alright, so next, moving on to the combination type of heat detectors. Now these kind of heat detectors are fairly more accurate because they involve both the fixed temperature and the rate of rise type of scenarios and functions to take place. Now the time that these heat detectors will give an alarm is basically the condition in which they will give an alarm is basically that if both the conditions of the preset temperature as well as the rate of rise in the temperature are met. That means that if the temperature goes beyond the preset temperature and the rate of and above the rate of rise temperature, only then will these kind of heat detectors confirm that there is an existing fire alarm and then send the signal to the FACP. So the next type of alarm initiating devices that we will be talking about are the combination or multi-sensor type of detectors. As the definition states, these are the devices that utilize multiple criteria or a combination of features in order to detect and initiate a fire alarm condition, which means that they are required to satisfy multiple criterias, uh, either two or more type of criteria or conditions to be met in order for them to generate a fire alarm signal. So because of that, there's another term that is used for these type of detectors, and that is also the multi-criteria type of detectors. So now the most common type of multi-criteria type of detectors or multi-sensor type of detectors that are used are the one that we've already discussed in heat detectors, that is the fixed temperature and rate of rise type of combination heat detectors, and B, the smoke plus heat combination type of detectors. So we will not be discussing the fixed temperature and rate of rise type of heat detectors, as we've already discussed them in the heat detector section. Also, I'd like to state that there are even more different types of multi-criteria detectors that are available nowadays. So, but we will only be discussing the most common type, and one of those common type we've already discussed. So, we will be talking about the smoke and heat combination type of detectors. So, moving on. So now let's talk about the smoke and heat combination type of detectors. Now, as you can understand from the name itself, it is basically these are devices or smoke detectors that use a combination of smoke detection plus heat detection in order to generate and confirm and generate a fire alarm signal. Now, for these kind of smoke detectors, for these kind of detectors, these combination detectors, to initiate a fire alarm signal, both the criteria of smoke detection plus heat detection need to be met. Now, in smoke detection, of course, these days the most commonly type of smoke detection method that is used is photoelectric type heat smoke detection, and whereas in the heat detection it could either be a rate of rise type of heat detector or a fixed temperature. So the fire alarm signal is normally generated when both the smoke criteria, the smoke detection criteria, plus either of the heat detection criteria are met. And then once this has been confirmed by the smoke detection, after both the criteria are met, then and only then do these type of detectors send a fire alarm signal to the FACP. So the next type of alarm initiating devices that we will be talking about are the flame detectors. And as the name itself suggests, that these are the devices that sense the radiant energy that comes from flames, from existing flames, in order to determine whether a fire alarm signal condition exists or not. Now, if the radiant energy that is coming from the flame is greater than the set predetermined value within the flame detectors, then it sends a fire alarm signal to the FACP after the confirmation of the existence of the fire alarm signal. So now there are namely three types of commonly used flame detectors. First are the UV flame detectors. Secondly are the IR or infrared type of flame detectors. And third are the combination type of UV plus IR type of flame detectors. Now we will discuss each of these flame detectors in a bit more detail. All right, so let's start off with just talking about the UV type of flame detectors. Now, these type of flame detectors, they detect the UV radiation that is coming from the flames and compare it with the preset value that is already within the flame detectors itself in order to determine whether a fire alarm condition exists or not. If a fire alarm condition exists, then the signal is sent to the FACP after confirmation. So now moving on, we will be talking about the IR type of flame detectors. Now, as the name suggests, these kind of devices are the devices that sense the infrared radiation that comes from the flame, and the same process is again followed, that it compares the value of it compares the IR radiation with the preset value of the IR radiation that is preset within the flame detectors, in order to determine whether a fire alarm condition exists or not. Once it is confirmed that the fire alarm condition exists, then the fire alarm signal is sent to the FACP. Alright, so the last type of flame detector that we will be talking about is the combination of the UV plus IR type of flame detector. And again, as the name suggests, it uses a combination of both the UV plus the IR criterias to determine the existence of a fire alarm condition, and then and only then, once the fire alarm condition is has been confirmed, only then it sends the signal to the FACP. So for this kind of combination type of flame detector, both the conditions of the UV and IR criteria need to be met, and the detector contains preset values for both the UV conditions and the IR conditions that need to be crossed over before it is confirmed that a fire alarm signal exists. So that concludes the flame detectors. Now, the next type of alarm initiating devices that we will be talking about are the gas detectors. As the name itself suggests, these are the devices that are used to sense the presence of different kinds of gases, and if the concentration of the gases are either above or below a predetermined value within the gas detectors, then they tend to send an alarm signal to the FACP or to any other panel to which they are connected. Now, these detectors can be connected either directly or via monitor modules to the panels. Now, they are usually either of 2-wire type or 4-wire type of devices. And some of the different types of gases that are commonly monitored by gas detectors are as follows: A. Oxygen for low level, B. Carbon dioxide, C. Carbon monoxide, D. Hydrogen sulfide, and so on. Next, the different types of gas detectors can be classified by the different types of processes that are implemented in the detection process. Some of the different types of gas detectors that are commonly used are as follows: A. The semiconductor type, B. The oxidation type, C. The catalytic type, D. The photoionization type, and E. The infrared type. Next, we will be talking about each of these types of gas detectors in a bit of detail. So let's start with A, the semiconductor type of gas detectors. Now, these type of gas detectors detect gases by chemical reactions that take place when the gas comes in direct contact with the sensor. This direct contact uh, uh, this direct contact reduces the resistance of the semiconductor material, that is the sensor semiconductor material, and due to this change in resistance is what determines the amount of gas that is present. What this means is that the gas is continuously sampled by the gas detector, and when the gas comes into contact with the semiconductor material of the sensor, it reduces the resistance of the semiconductor material, and hence this reduction in the resistance is what is directly proportional, or is what directly determines the amount of gas that is present within the premises. Now, B, oxidation type of gas detectors. Now, these type of gas detectors work by allowing the gases to pass through a porous membrane and then getting directly in touch with an electrode, come in contact with an electrode that is present within the gas detector. Now, when these gases get in touch with the electrode that is inside the gas detector, this causes these gases to get chemically oxidized or reduced. Now, due to this oxidization or reduction, there is a certain amount of current that is produced. Now, the amount of current that is produced due to this oxidization that is taking place between the gas and the electrode, this is what is directly proportional to the concentration or the amount of gas that is present within the room. That means that the amount of current that will be produced due to the oxidization effect that is taking place is directly proportional to the concentration of the gas within the premises. Now C, the catalytic type. This is a bit more complex as compared to the other types that we've discussed, and as the definition states, these are commonly used to measure combustible gases that are present within an explosive hazard. Now, these type of gas detectors they normally contain active and reference beads which contain platinum wire coils and are also located on opposite arms of a Wheatstone bridge circuit, which is electrically heated up to a few hundred degrees. Now, due to this heating of the Wheatstone bridge, there is a voltage difference that is actually produced between the active and the passive beads. Now, the active beads they contain a certain catalyst that allows the explosive gases or the combustible gases to oxidize when they come into contact with these active beads. Okay, and therefore, due to this oxidization, the heat or the amount of heat that is being produced further increases at the active beads, and it changes the electrical resistance of the active beads. Now due to this change in the electrical resistance of the active beads, the voltage drop or the voltage difference between the active and the passive beads also changes. Now this change in the voltage difference between the active and passive beads is what determines the amount of the combustible gases or vapors that are present within the premises. What this means is that the voltage difference between the active and passive beads that takes place uh, uh, due to the chemical reactions taking place within the gas detector is what is directly proportional to the concentration of these combustible gases and vapors. Now moving on, let's talk about the next type of gas detector, that is the photoionization type of gas detectors. Now, these kind of gas detectors, they usually use a high photon energy UV lamp that is present within the gas detectors to ionize the sample gases uh, that are present within the gas detectors. Now, if the sample gases have an ionization energy that is below the that of the photons that are being produced by the UV lamp present within the gas detector, then a current will be produced. And this resulting current, the amount of this resulting current is what is proportional to the concentration of the gases that are being sampled. That means that the amount of current that is being produced due to this ionization effect that is taking place inside the gas detector is what determines the amount of the gas that is present within the premises. Now moving on, let's talk about the infrared type of gas detectors. Now there are basically two types of infrared or IR gas detectors. One is the IR point type of gas detectors. Now these are the type of gas detectors that use the radiation passing through a unknown volume of gas, and energy from the sensor beam is absorbed at certain wavelengths depending on the properties of the specific gas. So what this means is that basically they use the radiation that is actually passing through volume of through a certain volume or known volume of the gas. Okay, so that means that these type of gas detectors they send a sensor beam, they fire a sensor beam at a certain known volume of the gas, and the different changes that take place within this volume of gas, different changes in the wavelengths that take place within the known amount of gas is what determines the uh, the amount of the gas that is present within the premises. Alright, so next let's talk about the IR imaging type of gas detectors. Now, these type of gas detectors, they include active and passive systems. For the active sensing, the IR imaging sensors that are present typically scan a laser through a the field of view of a certain scene and look for backscattered light at the absorption line wavelength of a specific target gas. Basically, what they mean is that the imaging sensors, they pass a laser across a field of view and look for backscattered light that might be at the absorption line wavelength of the gas that is to be detected. Now, let's talk about the next type, that is the passive IR imaging type of gas detectors. The passive IR imaging sensors measure the spectral changes at each pixel in an image and look for specific spectral signatures that indicate the presence of target gases. Now, in these kind of gas detectors, the passive IR imaging type of gas detectors are quite similar to video-based smoke detection system as well, because even in that the cameras or the imaging sensors, they search for certain spectral changes within the environment that is being protected in order to determine whether a fire alarm exists or not. In a similar way, these imaging sensors, they keep on monitoring each and every single aspect of the image that is present, and keep on looking for certain spectral changes that match the certain spectral signatures that match the signatures of the gas that is to be detected within the premises. Now, let me show you a few examples of uh, two types of gas detectors. So here you can see we have the basically on your left hand side you have the hydrogen gas detector. This is what basically looks like. Of course, you can instead of hydrogen, you can monitor any other type of gas as well. uh, they it's not necessary that they only monitor oxygen or hydrogen, etc. They can monitor a number of set of gases that might be present in the manufacturer data sheets. And on the right hand side you have, of course, the specific gas detector, that is the oxygen gas detector. As you can see, it is mentioned over here, right over here. So these are the two examples of your common type of gas detectors that are used. Alright, so the next type of alarm initiating device that we will be discussing are the manual pull stations. Now, as the definition states, these are the devices which are used to manually initiate a fire alarm signal. Now, they can be of either the addressable or the conventional types, depending upon this type of fire alarm system that they're being used in. Now, there are basically two types of manual pull stations that are used to initiate the fire alarm signal. First is the single action type, which means that these type of manual pull stations will usually require a single type of action, like pulling of a lever to initiate the fire alarm signal. And second type is the double action type, which usually require two actions, like the lifting of a flap uh, and pulling of a lever in order to initiate a fire alarm signal, or the pushing of a certain button inside and then pulling down in order to initiate a fire alarm signal. Means basically there are two actions that are taking place in order to initiate the alarm signal. Now let me just show you an example of the two types of manual pull stations that we have discussed about. So here you can see this is basically your single action type of pull station, in which you just need to pull down this lever that is over here, and once this has been pulled down, it will immediately initiate an alarm signal. And over here you can see the double action type of pull station. Here what needs to be done is you need to basically lift this flap up, and then you need to pull it down in order to initiate the fire alarm signal. So there are two actions: lifting of the flap and then pulling this second flap over here down. So that concludes the manual pull stations. Alright, so the final type of alarm initiating devices that we will be talking about are the flow switches. Now, they are the devices which are used to indicate the existence of a fire alarm signal due to the activation of an automatic sprinkler system. What this means is that the flow switches, they tend to activate and send a signal to the fire alarm control panel via monitor modules or input modules whenever there is the activation of an automatic sprinkler system. That means that if there's a flow of water within the automatic sprinkler system, then the flow switches, they activate and detect the flow and then send a signal to the fire alarm control panel via the monitor modules to indicate that there is an existing fire alarm condition within the protected premises. Then, as per this signal, the fire alarm control panel then takes a necessary action or uh, 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 a necessary action by activating the notification devices or transmitting the signal to the fire station or any other station that is responsible for the protection of the premises. Now moving on, we'll show you just an example of what a flow switch actually looks like. So as you can see, this is the vane type of flow switch. And what this means is that you have this vane over here that is inserted inside the main header or the main line of the automatic sprinkler system, and whenever flow takes place, then the water hits this vane, and when this whenever the water hits this vane, that is when this indicates the flow or the activation of the automatic sprinkler system, and hence this is connected to a circuit over here, which then sends a signal, which is then connected to monitor modules and then sends a signal to the fire alarm control panel via those monitor modules. Of course, this same flow switch can also be connected to other systems to indicate the activation of the automatic sprinkler system directly as well, such as the BMS system. So with this final device, this concludes the alarm initiating devices section. So the next set of devices that we will be talking about in the fire alarm system are the input modules. Now these are those addressable devices that are connected in the fire alarm system loop, which provide an interface between the fire alarm system and any other system or devices that need to be monitored by it. Basically, what this means is that they tend to receive signals upon the activation of these devices or systems. So, for example, if you want to activate the notification devices when an automatic sprinkler system activates, then that requires the flow switches that are connected on the system to be monitored by the input modules, so that whenever an alarm signal occurs due to the activation of the sprinkler system, the signal is transmitted from the flow switches to the FACP via those monitor modules, so that the FACP can then take the adequate response once the alarm signal has been initiated. Now moving on, we will be talking about the different types of input modules that are commonly used. First of all, we have the input modules can be either single input modules or multiple input modules. Now, single input modules can only receive a single signal input from the devices that are being monitored. That could be a number of devices, but will just receive a single signal that will be monitored by the single module. Now, whereas multiple or dual input modules have the ability to receive two or more input signals uh, by being connected to multiple systems or devices being monitored via multiple sets of contacts using just one single module device itself. Now, to make things more clear, I'll just show you a few examples of the type of input modules that are actually used. So here we have a typical single input monitor module, and as you can see, you have a number of devices connected to the set of contacts that are available within the system, within the device, sorry. And at the end of the last device that is being monitored by it, you will have an end of line resistor which is of 47 kilo ohms, and you can see that uh, 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 the connection for this addressable device comes from the panel or the previous device and then goes on to the next device within the loop. Alright, so this is the example of the single monitor module. Next, we will be talking about the dual or double input monitor module. Now, what this means is that there are two sets of similarly like the single input module, you have instead of one set of outputs that are used, you have two sets of outputs or contacts that are used in order to monitor multiple signals from multiple systems or devices that can be connected to it, and they're all connected in the same way with the 47 kilo ohm end of line resistor connected at the end. And even as you can see, the SLC connection is the same as well, the loop connection basically from the panel or the previous device. It comes in and then goes out to the next device. Now moving on to the multiple input monitor modules. Now this is the example of multiple input monitor module. Basically a 10 input monitor module. This is what we'll be showing over here. As you can see, the SLC is over here. It's mentioned over here. It's as shown over here, SLC. This is from the panel or the previous device and to the next device. Now here you can see you have like 10 sets of contacts: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And you can see that through one set of those contacts you have a number of devices or systems that are connected to it. This is typical IDC or IDC initiating device circuit, which is class B. And again at the end you have the 47 kilo ohm interfine resistor connected to it. So with this concludes the input module section. Alright, so the next set of devices that we will be talking about are the output or control modules for a fire alarm system. Now, as per the definition, these are the interface modules that are used to send output signals to other systems in order to perform certain functions in case of a fire alarm condition. For example, these modules can be used to shut down the HVAC system in case of a fire alarm condition in order to prevent the spread of the smoke throughout the premises. Now, there are mainly two types of output or control modules that are usually available and commonly used: A, the control modules, and B, the relay modules. So next, we will be talking about these two types of control modules in a bit of detail. So let's start with the control modules. Now, a control module provides supervised monitoring of wiring to load devices that require an external power supply to operate, such as horns, strobes, or bells. It is capable of Class A and Class B supervision. Now, basically what this means is that you can connect devices such as horns and strobes or bells and program the control modules to activate these devices that require external power supply to operate under certain conditions. For example, if you want to separate a certain part of the building or a certain room from all the other rooms, and you want a notification device to activate specifically when for that room, specifically when an alarm signal takes place within that room itself, then you can use this control module, program it in such a way that it operates these notification devices for that particular room itself whenever a fire alarm takes place within that room itself. Now moving on, let's talk about the relay modules. Now the relay module allows the control panel to switch two isolated sets of Form C contacts on command without supervision for the notification appliance circuit. Now what this means is that basically you have two sets of Form C contacts that are available in the device that are not supervised and without any sort of supervision, and basically whenever a signal is sent from the FECP to the relay module, it trips or activates either of these Form C contacts and makes the system that is connected to it perform the operation that it is required to perform. So, for example, you can use these relay modules in order to control the functioning of the HVAC system or the fire smoke dampers, etc. You can shut down the HVAC in case of a fire alarm using these relay modules. So that is basically the function of these relay modules. And of course, now I'll be showing you just one or two examples of these modules as well. So here, as you can see, this is the typical control module that is being shown over here. Now, as you can see, you have uh, again the SLC from the previous panel or previous device. The wiring will come into the device, and then from here it will, from the same connection itself, it will go to the next device in the SLC. Now here you can see the connection to the multiple devices that are connected over here, and the end of line resistors. It's quite similar to that of a uh, monitor module as well. And here, as you can see, since as per the definition it was mentioned that the devices connected to these control modules require external power supply, so here you can see the external power supply that is connected to the control module, and then it is being sent to these devices through the control module. So now here the next example is that of a typical relay module. Now here you can see you have two sets basically of you know form C contacts that are connected over here, that are shown over here, that can be used to perform any functions such as HVAC shutdown, or opening or closing of the fire smoke dampers, etc. And here again you can see the SLC line. This is the wiring that is coming from the previous device or from the control panel, and then going on to the next device. So with that, this concludes the uh, output or control module section. Now, the next topic of discussion for fire alarm systems will be the notification appliances. Now, as stated in the definition, these are the devices that provide a notification signal to the occupants of the premises about the presence of an alarm condition. This means that whenever there is a fire alarm condition existing in the protected premises, then these notification appliances will be activated and will provide notification to the occupants of the building that there is an existing fire alarm condition within the premises, thereby allowing the evacuation of the premises. Now, there are mainly three types of notification appliances that are commonly used for this purpose, namely the audible devices, the visual devices, and the audio-visual devices. Now we will discuss a few of the examples of these different three types of notification appliances. Now, examples of audible devices will be your bells, horns, and speakers. Namely, audible, as the name suggests, audible devices are the devices that just produce different sounds in order to notify the occupants of the premises. The examples of visual devices will be your strobes and beacons. Now, these provide visual aids or lights, rotating beacons or lights, red color or amber colored lights, in order to provide notification to the occupants about the existence of a fire alarm condition. Now, examples of audio-visual devices will be horn strobes combination, bell strobes combination, and speaker strobe combination. Now, this is basically a combination of both audible and visual devices that will provide both audible signals and as well as visual signals or aids to the occupants uh, about the notifying them about the existence of a fire alarm condition within the protected premises. So let me just show you a few images of the three different types of notification appliances. Here you can see these are some of the commonly used audible devices, fire alarm audible devices. You have the fire alarm bell, then you have the fire alarm horn, and the fire alarm speakers. Next up is the fire alarm visual devices. Now you have the fire alarm strobe, and then you have the fire alarm beacon. Now these are very commonly used throughout the world for fire alarm systems. Next, the third and final ones are the fire alarm audio visual combination devices. Now, so here you can see the fire alarm bell strobe combination. You have the strobe here and the bell here in as one single unit itself. So this will provide the audible signal. This will provide the visual signal. Here you have the fire alarm horn strobe. Here you have this the horn. As you can see, the speaker part over here, the horn part over here above the strobe part. So this will provide the audio signal, and this will provide the notification signal. And again you have the fire alarm speaker strobe. Now here you can see the speaker that will provide the audible signal in words. It will provide certain programmed message that will be played throughout the protected premises in the presence of fire alarm condition. And along with that you will have the visual aid or the visual signal provided here by the strobe in the same unit. So with that, this completes the notification appliance section. Alright, so the next thing that we will be talking about is the fire alarm system interface with other building systems. Now, as we all know that during the presence of a fire alarm condition within a protected premises, there are several other systems that need to be interfaced with the fire alarm system for various purposes. Now, some of those common systems that are interfaced along with the fire alarm system are the HVAC system for the shutdown of the air conditioning units. Then you have the other suppression systems such as the automatic sprinkler system, the clean agent systems, CO2 system, etc. Then you have the elevators for the elevator recall function, and after that you have the smoke management system, and of course last but not least we have the building management system, etc. Of course there can be even more systems such as the SCADA system, etc., to which it can be interfaced as well. Now moving on, uh, we will be discussing these systems in a bit of detail. First off, we will discuss the interface of the fire alarm system with the HVAC. Now here as per the diagram over here, you can see that the signal is once the smoke detector detects the presence of smoke or the fire alarm condition, the alarm signal is sent to the FACP, which then sends the signal to the relay module, and which is connected to the DDC panel. Now DDC panel is that panel which controls the HVAC units. So the signal from the relay module goes to the DDC panel, and this DDC panel then sends the signal to the HVAC unit, thereby shutting it down or closes the dampers, either which way. Alright, now moving on, the second example is that of the fire alarm system interface with the automatic sprinkler system. Now here you can have basically the activation of the sprinkler. Now a sprinkler normally is also considered as a heat detector because it functions on on the principle of heat detection itself. So whenever a sprinkler activates, it causes the flow switch to activate, and thereby the flow switch then sends a signal to the FACP via the monitor module, and the FACP then activates the building notification devices. So this is basically for the alarm signal, the sprinkler alarm signal connection. Then you also have the sprinkler supervisory signal connection as well. Now what happens is, if there is any sort of supervisory alarm that takes place within the automatic sprinkler system, then that signal is sent uh, back to the FACP via a monitor module. And again the LEDs within the FACP activate along with a sound on the FACP. So the next system interface that we will be talking about is the fire alarm system interface with the elevator for the elevator recall function. Now here again you can see the activation of the smoke detector is what actually causes the signal to be sent to the FACP, and which then sends a signal to the relay module, and accordingly the relay module is connected to the elevator controller, which then moves the elevator car to the alternate floor. Now this is basically done in order to allow the firefighters to gain access to the floor in which the fire is taking place. Basically what happens is that the elevator, if it is on the same floor as that of the fire, then the smoke detector will send the signal, will detect the fire and then send the signal to the FACP, thereby causing the elevator recall function to take place, and the elevator car will move down to the alternate floor, so that the firefighters can gain access to the elevator car and thereby reach the floor where the fire is taking place quite easily. Now, in this sort of a situation, only the firefighters can access the elevator car, and no other person can access it. Basically in this sort of situation. All right. So the next system that we will be talking about will be the fire alarm interface with the smoke management system. Again, what happens is whenever a smoke detector detects smoke or fire and sends a signal to the FACP will again send a signal via a relay module to the smoke management panel, which will then take the necessary action in order to allow certain you can say fans or other certain systems to activate in order to stop the spread of the smoke within the building. For example, the smoke management panel could be connected to a number of exhaust fans or certain windows, doors, or even cladding that could basically open up and allow the smoke to pass through and to stop it from spreading to other parts of the building. Alright, so the next topic of discussion is the fire alarm system networking. Now, as you all know that networking in a fire alarm system is basically interfacing between different control panels and other panels and devices to form a closed network or dedicated network to share all the information between them and monitor all the panels connected to the fire alarm system. Now, networking in fire alarm systems is usually done from panel to panel using network modules or cards that are installed inside the panels itself, and are also based upon the different mediums being used for the interconnection. Now, each of these panels or devices that are interconnected to each other are also called as nodes, and the interconnection that is formed between each of these nodes is what forms the fire alarm system. Now, there are basically two types of mediums that are normally used for the interconnection of all the nodes in a fire alarm system to form the network. The first one is the hardwired, that is basically using twisted pair copper wires to form the network, and the respective network modules or cards are installed inside the panels that allow for the interconnection between each of the nodes directly using the hardwire. And then the second medium that is used is of course the fiber optic cable, which offers a much faster communication option along and the respective network modules and cards again are installed inside the panels in order to allow the interconnection between each of the nodes using the fiber optic cables. Of course, you can also mix up both of these mediums as well. Means on from one panel to another, you could have let's say a hardwire interconnection, and as well as you could also have from a fiber optic connection as well. That depends upon the manufacturer and the and also the network module cards or cards that are installed within the panels. So now moving on. So here I'm just going to show you guys a block diagram of the different ways in which you can actually interconnect and form a network in a fire alarm system. So basically here you can see the right over here you can see the twisted pair cable or the copper wire or hardwired connections between panels. You can see how they are interconnected to each other using this one, and here you can see this NCM that is mentioned over here. That's a network control module or card that is installed inside the panel. Okay, so basically the type of card that will be installed, the type of NCM card that will be installed in the panel will be basically one to which you can connect the twisted pair cable, and similar kind of cards will be installed in all the panels to which this interconnection or the network is to be connected to. And of course then you can over here you can see you have the fiber optic cable as well. This is the NFN dual fiber optic link. So basically you will have a similar kind of card. If over here if this panel was connected to this panel and so on using fiber optic cable, then the NCM card over here would be of the type that would allow the interconnection between fiber optic cables. So that is basically the two main important mediums that are used for interconnection between fire alarm control panels to form the network. Of course, here as you can see that it shows other interfaces as well. What this means is that you can connect any of these panels to any a number of other devices that can be interfaced with these fire alarm control panels using other mediums such as Cat5 or Cat6 cables. Whatever is basically allowed as per the manufacturer, that is easily available, that can be easily found out in any of the manufacturer data sheets, etc. So this is basically another form of interconnection or interface that can be formed between printers and LCDs, etc., to provide additional information. So the next topic of discussion will be the types of fire alarm system cables. Now the most common sizes of fire alarm system cables that are used based upon the project requirements are normally your 14 AWG, 16 AWG and 18 AWG cables, where AWG stands for American Wire Gauge. Now of course you can utilize other sizes of cables such as 12 AWG based upon the site conditions as well. Now the different types of cables that are normally used for fire alarm systems are mentioned below. First off, we have the fire power limited cable, which is a power limited fire alarm cable and is usually the least expensive because it is the most basic type of fire alarm cable which is used and is also recognized by the NEC. Next, we have the fire power limited riser cable. Now these cables are suitable, are the same as the FPL cables, except for the fact that they can be used in vertical runs throughout the building through a shaft or from floor to floor. Basically they can be used in risers. And now the third type of cable that can be used is the fire power limited riser shielded cables. Now the only difference between the FPLR and the FPLR shielded cables is basically that it includes the FPLR shielded cable includes an aluminum polyester foil shield and a drain wire to protect against outside interference. That is the only difference, and again this is also a riser cable. Now moving on, the next type of cables that we have are basically your FPLP and FPLP shielded. Now the P here stands for plenum. So what this basically means is that these are power limited plenum cables which can be used in air ducts and plenum spaces and any other spaces that are used for the flow of environmental air. Now these cables, they tend to be a little bit more expensive due to the additional engineering and the protection that they offer. Now again, these cables are listed as having adequate fire resistance and low smoke producing characteristics as well. That makes them even more expensive as compared to your FPLR and normal FPL cables. Now again, the FPLP shielded cables, they'll be even more expensive as these cables, they also contain an aluminum polyester foil shield and a drain wire to block any sort of interference that might that might occur during installation. Now moving on, the next type of cable that is used is your non-power limited fire alarm cable, that is the NPLF. Now these kind of cables are general fire alarm cables and can be used anywhere at all. And of course the only place that these cables cannot be used are in plenums, risers and any other duct unless and until they are installed inside conduits, which means that if you're going to install them in a riser or a duct or a plenum space, then they need to be present inside a properly installed conduit. You cannot directly install them inside just like that. Now moving on, you have the non-power limited fire alarm cables for plenum, which again NPLFP means the P at the end just basically means that these cables can be directly installed within ducts, plenums, and other places where environmental air flows without installing them inside conduits. So this concludes the types of fire alarm cables that are normally used during installation. Alright, so now finally moving on to section 2 of this course, that is basically designing a fire alarm system. So the topics that will be covered during this section are 1. Determining the project scope and acquiring the required documents, and 2. Designing the fire alarm system itself. Now this second portion or second part of the section is basically divided into more subsections, that is basically preparing the cause and effect matrix, building layout drawings, SLD drawings or riser drawings, general installation detail drawings, the battery sizing calculations, and the voltage drop calculations. So what we will be doing in this section is basically discussing uh, the preparation of all of these documents in detail along with the first section. Alright, so the first topic of discussion for this section is going to be determining the project scope and acquiring the required documents. Now, before beginning the actual design process for the fire alarm system, it is important to determine what the requirements for designing the system are. For this, we have to start off by considering the first basic point mentioned in the beginning of the article, that is determining the project scope and acquiring the required documents. This is the initial and by far the most important step to consider, as it determines where the design of the fire alarm system goes from here. Now, the best way to determine all the requirements is to go through all the project specifications to make sure that nothing is missed and all the necessary points relevant to the project have been considered. Also, if there are any sort of preliminary design drawings that are available from the client, then it is advisable to check those drawings as well to see what points have been taken into account in those drawings and what changes might be needed to be made in the existing design. Of course, if the project has to be designed from scratch, then just checking and using the relevant architectural plans is enough, while following NFPA 72 and any other local standards that might come into play, unless of course the client has some specific requirements or performance based criteria which might need to be considered during the design stage. Now what this means is that basically the client might have some specific spacing considerations, or might have some specific requirements for a certain hazard or a certain uh, building or a room that might need to be considered. So that needs to be taken into account during the design stage as well, after discussing with the client. So moving on to the next part of this section, that is designing the fire alarm system. So the next step that comes into play once all the project requirements have been determined is to start making the design itself. Now this, as we know, requires the utilization of all the approved and scaled architectural drawings in either AutoCAD format or any other software format such as MicroStation, etc., along with all the other documents or approved documents that will be used for the preparation of the cause and effect matrix, the design drawings, the battery sizing calculations, and the voltage drop calculations. Now, having said that, let's move on to uh, the first document that we will be talking about, that is basically the cause and effect matrix. Now this, as the name suggests, is the document that determines the cause of any sort of alarm, trouble, or supervisory signals, or any sort of input signal and the effect or the type of output that the system will provide in response to the input received from the input devices. Now, these signals could be from a smoke detector, a manual pull station, a heat detector, a sprinkler flow switch connected to a monitor module, etc. Now, let's say, for example, if a smoke detector in the elevator lobby produces an alarm signal, then the output or effect that it will produce through the system will be the elevator recall function and the activation of all the notification devices throughout the premises. Or let's say that if a sprinkler flow switch activates, then the signal is first transmitted to the monitor module, and from there it is sent to the FACP, and in turn the FACP turns on the notification appliances. That means that the cause was this the turning on of the or the actuation of the sprinkler flow switch, and the output or the effect was the FACP turning on the notification appliances. So now let me give you an example of what a fire alarm system, fire alarm cause and effect matrix actually looks like. This is normally what it will look like. You know, on one side you will have all the system inputs or the causes that will cause all these system outputs that will be represented on the other side. So let's say, for example, for all the trouble signals such as the fire alarm module failure, open circuit, ground fault, battery failure, and AC power failure, etc., you will have these effects or these general effects that will come into place, that will take place on the FACP. These are the general effects that will take place. That is namely, first of all, there will be annunciation at the FACP. That means that it will display what kind of trouble signal it is, and along with that there will be an LED that will keep on blinking on the FACP. And this is common for all such for all the signals, almost all the signals. It will do the same thing, even including for alarm signals as well. And you will have a certain tone that will activate on the FACP for all these signals too. Now, moving on, let's say that you have let's say an alarm signal through a duct smoke detector or a smoke detector. Then you will still have the general output that is shown right over here, along with other outputs that will take place once the FACP receives the signal from the duct smoke detector. In this case, upon the activation of the duct smoke detector, you will have the general notification on the panel with the LED and the sounder. At the same time, you will also have the FACP taking action, and that is basically shutting down all the HVAC units for that particular building and closing all the fire smoke dampers. Similarly, if you have a flow switch or a smoke detector activation, then you will, let's say for the flow switch, you will have all of these actions taking place. That is basically you will have the sounders within that particular zone where the flow switch is located, and then the releasing of all the electrically closed doors along with the HVAC shutdown, and you will have the AHU shutdown, and at the same time you will also have the closing of the smoke dampers, etc., as you can see all shown over here. So this is basically what what a fire alarm cause and matrix does. Now the programming itself for the fire alarm system will be based off on this. As you can see that these inputs will be programmed into the fire alarm control panel, and along with these outputs. So now moving on, the next subsection that we will be discussing are the design drawings for the design of the fire alarm system. Now the design drawings will be prepared by taking into account the following below points: the dimensions of the rooms or areas being protected, the type of detectors or devices to be used for the particular areas being protected, the spacing and coverage of the detectors being used, all the types of other relevant devices coming in the areas and their spacings, if any. Module, for example, you have modules, pull stations, notification devices, etc. Then the spacing of detectors from HVAC return and supply diffusers, the spacing of detectors from electrical lighting. Now, when I say detectors, this includes both smoke and heat detectors. Not just It's not just restricted to smoke detectors. Then you have the reflected ceiling plan, which normally doesn't consider any spacing for any of the devices. That means that what normally, as per my own experience, what I've normally seen is that all the devices will be placed in a single straight line without taking into consideration any of the spacings as per NFPA 72, which can affect the design drastically at a later stage and can also affect the installation of the devices. And then of course the final point is the interfaces and the signals between all other systems such as BMS, HVAC, elevators, automatic sprinkler systems. They all these factors, all these things have to be considered during the design stage itself. Even NFPA 72 mentions the same thing. So it is advisable to make sure and consider all of these points during the design stage itself, in order to avoid any sort of issues or problems that might occur later on. So then moving on, now there are several design drawings that are prepared during a complete system design, and some of them are mentioned here below. It's not just the layouts, you have the SLDs and the GIDs as well. So the first type of drawings that we will be talking about are the building or premises layout drawings. Now, as the name suggests, these are the drawings that display the layout of the premises being protected, with the locations of all the devices and the conduit routings shown as required for the system. Now, this is the most important drawing in the design process, as it shows the locations and distances at which all the devices that are in the fire alarm system, as well as the equipment that is interconnected to it with the fire alarm system, are all located within the premises. Basically, it shows the location of everything, so that is why this is like literally the most important drawing, and all the other drawings are derived from this drawing. Now the smoke detectors, heat detectors, manual pull stations all have certain distances at which they need to be placed from either the wall, the door, or from each other. For example, while designing a fire alarm system, the standard spacing that is considered for smoke detectors is 9.1 meters from each other, taken from the center of each smoke detector. And from the wall, the distance for a smoke detector is 4.5 meters maximum. It cannot exceed beyond 4.5 meters from any wall in a room. Now, for heat detectors, the maximum spacing between detectors is 15.1 meters, and for manual pull stations, normally the manual pull stations are placed near the exit doors, and of course they cannot exceed 1.5 meters distance from any of the doors. And of course, in any as per NFPA 72, in any horizontal run of a straight corridor, there has to be at least one manual pull station to be placed within that horizontal run of the corridor. So then moving on, this is basically a typical layout drawing that I'm just showing you right over here. As you can see over here, you can see the smoke detectors placed all over here, and this CV, it stands for ceiling void. Means this is above ceiling, above the false ceiling smoke detector. Okay, so you have one smoke detector for the room, you have one smoke detector for the ceiling void as well. Then here you have the FACP placed over here. This is where as you can see, it shows that this is where the loop is starting, and then this is loop 1 is starting, this is where loop 2 is starting, this is where the loop is ending. That's loop 1 that is ending over here, and this is loop 2 that is ending from over here. At the same time, you can see the heat detectors placed in their respective places. Then you have the monitor modules, you have the LEDs. uh, what else can we show you here? Yeah, you have a set of monitor modules and other control modules, etc., shown over here. And then you can see the notification appliances here. Then you have the MPS, the manual pull station. Like I said, this is basically this is one of the doors, and it's right next to the door along with the notification appliance. So yeah, this is basically your general system layout drawing. This is not exactly how it will look like, but this should give you a clear idea of what it's supposed to include, and what all details you can provide in this one. Of course, they've not mentioned the dimensions or the distances from the wall and between the detectors in this one, but it's always a good idea to include those in the design as well. All right, so now moving on. Of course, like we mentioned earlier, that the smoke detector spacing is normally 9.1 meters. It's considered as 9.1 meters as per NFPA 72. Of course, there are basically three design methods of placing the smoke detectors as per NFPA 72. The first criteria that is considered is the performance based criteria. Now, in this type of design, the spacing is usually done based on the input received from the AHJ, that is the authority having jurisdiction, or the client, as to how they want the system to perform. For example, a client could request a designer to design a system based on a smaller coverage area of the smoke detector. Therefore, when the designer would design the system based on the requirement of the AHJ, it would result in a system requiring more number of smoke detectors. All right, that means let's say that you have the spacing or the coverage that is a lot less than 9.1 meters. Let's say it's around 6.3 meters, then that would increase the number of smoke detectors, because you based on the requirement of the client, you will be designing the system based on that. So therefore it will actually exceed, not exceed, it will actually increase the number of smoke detectors that will be placed as per the requirement of the client. Okay, now if now and in normal circumstances, what happens is that the client will tell you to go to and follow NFPA 72 itself. Okay, so when that happens, when there is no performance based criteria, means the AHJ just tells you that all right, go ahead and design the system based on NFPA 72. That's when the nominal spacing and the other third type of spacing come into consideration. Now, the nominal spacing is the most common type of spacing, that is 9.1, that is followed during the design of any fire alarm system. Now, this is the easiest to follow as well. This is the spacing which is normally used for the design of smoke detectors in almost all designs in the absence of any performance based criteria from the AHG. Now, the nominal spacing is mentioned in the below table as 9.1 meters as per NFPA 72 between detectors, and half of that distance from a perpendicular point on any wall, meaning 4.5 meters from a perpendicular point on a wall. Means at 90 degrees, the distance of the smoke detector should not exceed 4.5 meters, and between detector to detector in any room or any area, it should be 9.1 meters. Now, we've also mentioned that there's a below that there's a table over here as well. We'll get to that once we complete this section. Now, the third spacing, this is basically a third spacing. This third spacing considers the distance of a smoke detector as zero point 0.7 times S, or zero point 0.7 times the nominal spacing from all points on the ceiling of any area. If the designer considers this spacing for the design of a fire alarm system, then the spacing increases from 9.1 meters between the detectors to 12.74 meters, as the distance from any point on the ceiling would be zero point 0.7 times 9.1, that is 6.7. Now here, this is the interesting point over here is that 4.5 meters is basically, if you consider the coverage of a smoke detector as a circle, then 4.5 meters is basically the radius of that circle, and 9.1 meters is the complete diameter. So the same thing applies here. Now, if you consider 6.37 from any point on the ceiling, that will basically form a circle with a radius of 6.37 meters. That means that the complete diameter will be 12.74. So that's how you get the distance between the smoke detectors. All right. All right. So now, of course, this third category of spacing is normally more helpful and considered normally for irregular shaped areas. means areas that might have an irregular shape where you cannot get 4.5 meters or 9.1 meters spacing between detectors, etc. In that case you can consider this 6.37. And this comes, for example, you have, let's say you have corridors. In corridors, since it is an irregular shaped area which is quite long, you can't actually place too many smoke detect I mean, you cannot normally place the smoke detectors within the corridor. You can consider 9.1 meters, but then that will increase the number of smoke detectors if the corridor is too long. So in order to reduce that, this third point is very helpful, uh, because then utilizing this spacing between smoke detectors, you can reduce the number of smoke detectors in those particular areas. So now moving on, this is basically the table that we were talking about. Now as you can see over here, we mentioned that the smoke detector spacing from center to center, this spacing between detectors from center to center of the device, and half that spacing from the wall is 9.1 meters. This is also this spacing is also mentioned in almost all the data sheets of all the manufacturers as well. This is as per NFPA 72. Then again for heat detectors, again it is 15.1 meters mentioned, again with all the within all the data sheets of all the manufacturers. Then you have the manual pull stations, 1.5 meters from any building exit. The manual pull stations, 30 meters, or like within 61 meters, at least one needs to be there in the center. So there you have 30 meters from there for corridors. And then of course you have the input and output modules, which need to be at least 1 meter near the devices that they are going to be connected to in order to get a proper connection. Then of course the spacing from of smoke detectors and heat detectors from HVAC supply and return registers is 910 mm, which is 0.91 meters, taken from the edge of the registers, and this can be found in both NFPA 72 and NFPA 90. And of course the spacing from lighting, electrical lighting, is 300 mm or 30 centimeters or 0.3 meters. Okay, so this is basically standard practice, and this is normally followed out in order to avoid interference of any sort taking place within the system. And here we have the notification devices spacing as per NFA 72 as well. This is normally your height. This is normally your height that is considered over here for audible devices, for visual devices, audio visual devices, outdoor devices, and visual combination devices, etc. You can see all the spacing that is mentioned over here, all as per NFPA 72. Of course, the 4 meters is the standard that is followed for every system normally. So that's why it's 4 meters. It's not mentioned in NFPA 72 over there, but all the others are mentioned in NFPA 72. Alright, so the next set of drawings that we will be talking about in the design drawings is are the single line diagram or the riser drawing and the general installation drawing. So basically what we'll do right now is that I'll give you a quick rundown of exactly what these drawings are, and then we'll show you a few examples of these drawings to give you an idea of exactly what these drawings represent, and uh, and then move on from there. Alright, so starting off with the single line riser drawing. Now this is a representation of the interconnection between all the devices and the routing of the loops. It shows all the devices connected in the loop from first to last with their addresses or tagging, as well as any other equipment or systems that the devices might be interconnected to. Now this drawing can only be made once the layout drawings have been prepared and the routing has been laid in the layouts along with all the tags. Yeah, so as the definition itself states, this is just a single line representation of the entire design that has been laid out in the layout drawings, along with the not only the that includes not only the devices, or the fire alarm devices and all the other system devices that they are connected to, but also includes all the conduit routing and the number of cables the tagging of each and every single device, etc. as well. So it's just a single line representation of the layout, which gives a clearer view of which device is first, which device is second, and this also helps in programming the devices as well. So then now the second drawing that we will be discussing is the general installation drawing. Now this is the drawing that shows the installation details of all the devices being used in the system. It gives an idea of the heights at which the devices have to be installed and also how the devices need to be installed in certain locations and situations. Now this drawing basically is that drawing that you can normally find, even like you can get a lot of the details in the manual installation uh, data sheets as well, or in the installation manuals as well, and as well as the mounting heights or the mounting or installation spacing and the heights at which these devices need to be installed. For example, for a manual pole station, the height at which it needs to be installed from the finished floor level, and the distance that needs to be from the uh, from the door. Of course, the distance from the door doesn't necessarily need to be uh, you know shown in the general installation details, as it's already available in the layout drawings. But if you need to show something like that, you can show it. All right, so now let's move on to some examples of these drawings. So all right, so here we have a single line diagram, or the riser diagram, shown over here. So as you can see, you've got a loop that's shown over here, which starts from here. This is basically the first device, second device, which is a smoke or heat detector. Smoke slash heat means it's a combination detector. It's a monitor module, and then you have another monitor module. Then you have the manual pole station, manual call point or manual pole station. Then you have the other smoke detector, and you have all these devices that are connected in this particular loop, and then it just returns back to the panel. Now this module is basically the isolator module that you have. Normally nowadays you have the panels that come with a line isolator module that's already present inside the panels, but you can install them separately as well if needed. Okay, so that this is basically what a loop is, and you can represent the location of all these devices or the loop as well by just making a box like this and writing the name of the building either inside or outside the box. All right, so then of course you can see you have the um, you know the single line representation of how the FACP, the main firearm control panel, being connected to the graphical interface unit and then to the network command center or the graphics PC. And then at the same time you can see how this panel is actually connected, or this system is actually connected to the network and linked to the PA system, the firefighting system, the BMS system. uh, you know then it is also connected to the health clinic, to the admin building, and all the other buildings that are over here as well. And also it's interconnection to the repeater panel. So basically this just gives you an idea or a single line representation of where exact I mean of all the interconnections and everything that is connected to the fire alarm control panel. And also you can see the main power supply line being connected over here, shown as a single line as well. That's the reason, but since everything is shown in a single line using a single line, that's the reason why it's called as a single line diagram or a riser diagram. Now then, moving on to the next, that is the general installation details. Yeah, so this is basically your standard general installation details that are normally provided. Like in almost every project, you'll have a common set of installation details. For example, you can see the manual call point installed at a height of 1200 mm over here. Brake call point, false ceiling, concrete. You can see how the conduit is being run over here. You can see the back box over here, and what kind of wall this is. This is the finished floor level, the device itself over here. So these are basically the mounting heights that we were talking about. And again here for the this is for the sounder. This is the sounder. You can see the conduits and everything. You have the false ceiling, you have the size of the conduits mentioned in all of these, and you have the mounting height, that is 2300 mm. That's 2.3 meters above the finished floor level, FFL, like it's mentioned over here. All right, so then you have again you have the floor switch and tamper switch installation, switch modules installation, basically the monitor modules that will be installed, switch module. So this is basically what's shown over here. Again, 2.3 meters is the height that's been shown as per this drawing. Of course, that can vary based upon the location of the floor switch and the tamper switch. Right. So basically, this drawing gives a rough idea of how to install the devices. And here you have the smoke detector installation for a false ceiling. If there was no false ceiling, you could install it directly to this back box over here, but here you'll need a flexible conduit shown over here with supports, and then the back box. You can see here all the back boxes, the conduits, and the supports that are needed in order to hold the smoke detector in place along with the smoke detector itself. And see here you don't have any false ceiling. You can see how the smoke detector has been installed on the ceiling itself. Then here you have the installation details of a back box or a back box or a cabinet that will hold a number of modules inside it that will be connected to several other devices. So this is basically what a general installation detail actually shows. And again, this is just a close-up of all those drawings that we were discussing over here. Like I mentioned, you can see all the details presented over here for the sounder, just like this. Again, for the smoke detectors. So the next document that we will be discussing is the battery sizing calculations. Now these calculations are done to determine the size of the backup batteries that are installed and connected to the FACP in order to provide backup to the system as per NFPA 72 for 24 hours, and should be able to operate all the equipment for 5 minutes in case of an alarm condition for the purpose of evacuation of the occupants. Now the calculations also need to consider a minimum of a 20% margin above the calculated ampere hour capacity required. All of this is needed to get the right size of the batteries needed to provide the required amp hour rating for the system. Now the battery calculations take into account both the total standby current and the alarm current of the devices into consideration to calculate the size of the batteries based on the load. Alright, so what this basically means is that these calculations are basically done to determine the size of the backup batteries that will be connected to the FACP in order to provide backup to the system for 24 hours in standby condition, and in alarm condition for 5 minutes for the purpose of evacuation of the occupants. Now, of course, we don't consider the exact calculated ampere hour or size of the battery that is basically used. We have to consider like in order to get the actual ampere the battery size or ampere hour rating of a battery, we need to consider 20% of margin above the calculated value. So if let's say if you have like 35 ampere hour, then you need to consider plus 20% of that as well and include into this in order to get the actual ampere hour rating or the size of the battery. And even after that, it's always better to consider the battery size at least one rating higher than or the next rating higher than what you've actually calculated, in order to take into account any sort of differences that might occur due to changing of devices or whatever. So anyway, moving forward, the formulas that are used to calculate the total battery size in ampere hours are as follows. That is, AHS is equal to AS into HS, and AHA is equal to AA into HA. and total AH or ampere hour rating is equal to 1.2, that is the derating factor, into AHS plus AHA. Now where AHS is the standby condition ampere hour, total AH is the total ampere hour rating of the battery, AHA is the alarm condition ampere hour rating, AS is the total standby current of all devices, HS is the number of standby hours, AA is the total alarm current of all devices, HA is the number of alarm hours, and 1.2 is a constant that is used to derate the battery to assure a 5-year life, or in short, it is the derating factor, as I mentioned over here previously. Now this is what you can actually, these are the formulas that you can actually use to calculate the battery backup. Of course, don't forget to add the 20% margin as well into this to get the actual battery size. Now moving on, I'll show you a sample battery calculation sheet from NFPA 72, and I'll also show an example of how the battery calculation can be done. So here we have the battery calculation worksheet. As you can see over here, you have the total supervisory current or current draw worksheet. That is basically for the total standby current. This basically takes into account all the standby current of all the devices when they're in the standby mode. Basically, that is like when they're not in an alarm condition, each and every single device will draw some small amount of current. So you take the total of that current and put it over here. Okay, that this is basically the total standby current. Then you have the number of standby hours, that is namely 24 and 60 for NFPA 72. For our convenience, we'll consider the standard one, that is 24 hours as per NFPA 72. So 24 hours for standby current. Okay, then now what we do is we multiply this total current into the standby hours. That, let's say, I'll explain the calculation in the next uh, sheet. So then you'll get, once you multiply A and B over here, rows A and B, you'll get the total ampere hours, standby ampere hour during standby. Now for the total alarm current, again all the devices, they will also have a current draw that will be much larger than the standby current draw. And then you just take a total of the amount of current that will be drawn for all the devices, or the total alarm current. Okay, and then again, like for example, for let's say that you need to operate it for at least 5 minutes. You need to operate all these devices for at least 5 minutes in alarm condition. In that case, you can take 0.084 and multiply it with the total alarm current in order to get the total alarm ampere hour rating. And then once you get this, you can add both the total alarm ampere hour rating and the standby ampere rating in order to get the total ampere hour rating, and then multiply that with 1.2 in order to get the complete and actual battery size with the ampere rating. Now let's move on to the next sheet. That is basically the example that I was talking about. So here what we've done is we've taken the total current draw during standby as 1.2 amperes. This is for all the devices that are connected in the loop and that are consuming current in standby condition. And then we've considered 24 hours over here. So when you multiply both these two, you get 28.8 ampere hour as the total standby ampere rating. Okay. Then similarly for the current ampere rating, total ampere current rating, you get, let's say, like in the current state, in the alarm condition, basically you get a total ampere rating of 2 amperes. Okay, and then you want all the devices to be activated for, let's say, 15 minutes, not 5 but 15 minutes. So that means it is you get 15 divided by 60, for an hour, then you get like 0.25 is basically what you'll get, 0.25 hours. So now what you do is, in order to get the total alarm ampere hour rating, you multiply 2 with 0.25 to get this as zero point 0.5. Now you add both line C and F over here, and you get an total ampere rating of 29.3, which is then multiplied with 1.2 to get the actual and final ampere hour rating that is required by the system. Now again, this has to be you need to take at least 20% of this as well, which they've not shown in the sheet, and add it over here to get the complete ampere hour rating. And as it is mentioned over here, use next size battery with capacity greater than what is required. This is again like what I mentioned over there in the start, is that you need to consider a higher battery rating than what you actually calculate, even after including 20% margin, in order to avoid any sort of voltage drop or any sort of condition that might occur after the installation of the devices. Alright, so the final topic of discussion for this section will be the voltage drop calculations. Now, the NAC voltage drop calculations are critical for determining if your notification appliances will in fact work with the provided head-end equipment or not. This is of course based on the installation contractor installing the system as per the plans and the noted wiring distances. Now, if you perform your NAC voltage drop calculations correctly at the time of design, you will know exactly how many remote power supplies and NAC circuits are needed, as well as the wall space requirements and the 120 VAC connections required by the electrical contractor. Now, to just keep this in mind that this is a requirement of NFPA 72. Now, there are primarily two methods to perform a NAC voltage drop calculation. These methods are better known as point to point or PTP method, and the EOL or end of line method. Now, the PTP method requires much more math than the EOL method and is more complex. However, the extra work in the that is involved in the PTP method pays off, as this method is much more accurate as compared to the EOL method. So now moving on, we will discuss both these methods in a step-by-step manner. So let's start off with the end-of-line method. So the first step in this method is basically to add up the total current draw for your entire notification appliance based on the manufacturer type. Type means based on the manufacturer, the type of equipment that is strobe only, horn strobe, mini horn, audible level, wall, ceiling, etc. And of course, we have to make sure to consult with the appliance documentation to get all these values and figures. Now, the step 2 will be to add up the total wire length for the entire run and multiply it by 2 if it is a class B. Of course, if it's not class B, then you can just take one entire run itself. Now, the 2 represents the number of conductors used in the run. Now, the next and the third step will be to multiply the total wire length times the wire resistance value per foot for a total circuit wire resistance. Now, this wire resistance per foot can be found in table 8 conductor properties in chapter 9 of the National Electrical Code, or NFPA 70. The next step in the end of line method will be step 4, that is, now using Ohm's law we know that current into resistance is equal to voltage. So simply take the total current found in step 1 and multiply it by the resistance that has been found in step 3. Now this will give you the volts drop. Now the final step in this method is step 5, that is, subtract the volts dropped from the panel power terminal cutoff voltage to obtain the voltage that will be supplied to the last appliance on the circuit. Now this value must exceed 16 volts. Okay, so now keep in mind that this method is not as accurate as the point to point method. This method assumes that the voltage drop at each appliance will be the same, when in reality they are not. So that is the main reason why this method is, it's simple, it's easy, but it is not as accurate as a point to point method. So now moving on, let's talk about the point to point method. Now, this is just a small breakdown of what the calculation is actually like. Calculation breakdown. So, to perform a point to point voltage drop calculation is basically the same as the end of line method. However, we are going to do a breakdown of each path and appliance. So, the first calculation, first wire run section resistance multiplied by the total current for appliance V1, for appliances V1, V2, V3 and V4. Subtract the total from the terminal cutoff voltage to get the voltage drop for V1. So what we do is basically we get uh, the voltage drop V1 for all of these appliances. Okay, now when we get this, we have to subtract this total from the terminal cutoff voltage in order to get first V1. Okay, now in the second calculation, the second wire run section resistance multiplied by the total current for appliances V2, V3 and V4. So now the second wire run will be from the start to V2, V3 and V4 without including V1. Okay, now this once you get this total volts dropped is what we will subtract. Now basically what we will do is we will subtract V1 from the cutoff voltage, uh, a terminal cutoff voltage, to get a voltage drop V2. Okay, now the third calculation method is basically the third wire run section resistance multiplied by the total current for the appliances V3 and V4. Now what we have to do is basically we have to subtract the total of V2 from the terminal cutoff voltage to get the voltage drop of V3. Okay, next the final step in this is basically the fourth wire run section resistance multiplied by the total current for V4. Okay, now this subtract V3 from the total cutoff voltage to get voltage drop of V4. Now if this last value of V4 is greater than 16 volts, then the circuit should work. Now this method is basically more accurate as it gives us the voltage drop for each and every single point